We're now going to look at how to identify magnesium ions, barium ions, sulfate ions, halide ions and hydroxide ions. All these reactions involve precipitation reactions. So that is a reaction where we take two solutions, so that's two things with an aqueous state symbol, and we create an insoluble solid from those two, and therefore we see a precipitate with a colour. So we take a positive ion, could be 1 plus, could be 2 plus, and we react it with a negative ion in solution. So these are both AQ. So we'll be able to see through them. They might have a colour, but we'll be able to see through the solution, and we make a solid precipitate. To identify a positive ion, we need to add a negative ion, and to identify a negative ion, we need to add a positive ion. And because we're doing precipitation reactions here, we can only use solutions for these tests. We can't use solids. So if we had a solid compound, we would need to first of all dissolve it in water, deionized water, to not add any other ions before starting the test. So to start off with, we're going to look at magnesium, barium and sulfate in this video. So how would we test for a magnesium ion? Well, to test for a magnesium ion, we want to make the insoluble or sparingly soluble magnesium hydroxide. So if we want to make magnesium hydroxide and we've already got the magnesium ions in our solution, then we would add something containing hydroxide ions. So for example, sodium hydroxide. We'd put 1 centimetre of the sample to be tested in a test tube, then add 1 centimetre cubed of sodium hydroxide. We wouldn't want to add too much of either one. We want to be able to see our reaction occurring. So, for example, if we were testing a solution that contained magnesium ions that was, say, magnesium chloride, we would take our magnesium chloride in the test tube. We would add sodium hydroxide. So these would both be solutions. We would make magnesium hydroxide. Now, magnesium hydroxide is sparingly soluble, so we would see the precipitate, and our other product would be sodium chloride solution. We've balanced this equation. Because there's two Cl's, we put a 2 over here, and because we've now made there be 2 NAs, we put 2 over here. We could turn that into an ionic equation. It's the magnesium ions that we're testing for and needing a negative ion to react with, so the hydroxide ions, and they are creating our solid. So where our positive result for this test is the precipitate, white precipitate of magnesium hydroxide. So we would see a white precipitate of Mg brackets hydroxide ions twice, and that's our positive result. Our next test is to see how we would test for barium ions. So again, we're looking for some insoluble product of barium, and we know that barium sulfate is completely insoluble. So we want to add a reagent that contains sulfate ions. So our reagent could be maybe sodium sulfate solution or sulfuric acid. These all contain sulfate ions. Again, we put 1 centimetre cubed of our sample in the test tube and 1 centimetre cubed of our testing reagent, so sodium sulfate or sulfuric acid. So for example, again, if we were testing the chloride of barium, so this is our solution, we would take our barium chloride solution and add the sodium sulfate solution. We would get the insoluble precipitate of barium sulfate. Remember, barium sulfate is insoluble, so that would be the solid state symbol, and then we would get sodium chloride, which is soluble, so that would be AQ. Balance our equation, and then again we could turn that into ionic equation. Ionic equations are so beneficial for precipitation reactions. We're testing for barium ions, and we're using sulfate ions to do that, and we're making the precipitate. So these equations always form the precipitate you want from the two ions they're made from. Again, because barium sulfate is a group 2 solid, we would see a white precipitate of barium sulfate. So we have a couple of questions here. Why is it not possible to use sodium sulfate to identify Mg2 plus ions? Well, MgSO4 is soluble. Barium sulfate is insoluble. Magnesium sulfate is soluble. The solubility of the sulfates decreases down group 2. So no precipitate forms. We would observe a colourless solution. And we started with a colourless solution and we would observe a colourless solution. So there would have been no change in our reaction vessel. Why can we not use sodium hydroxide for barium ions? For the sort of same reasons. Barium hydroxide is soluble. So no precipitate forms. The solubility of the hydroxides decreases down group 2, with magnesium hydroxide being the least soluble hydroxide. So a colourless solution again is all that could be observed. And that's what we had at the start. So that's testing for magnesium and barium ions. And in this video, we're also going to look at testing for sulfate ions because it links directly for testing to barium ions, because if we want to test for sulfate ions, we also want to make the insoluble barium sulfate. And so we want to use a reagent that contains barium ions. So a barium salt, not barium sulfate though, because that's what we're trying to make. So usually barium chloride is used. So for this test, we put 1 centimetre cubed of the sample in a test tube and we actually add nitric acid first. And we add the nitric acid because in solution, there are other ions present that can react with barium. So for example, if there are carbonates present in the water, which is quite likely from carbonates in limestone rock that the water may have run over, then we will get barium carbonate. And barium carbonate is a white solid as well, an insoluble solid. And so if we are making a white solid from the water, we won't know whether we've made a white solid of barium sulfate. It will be a false positive. So we add nitric acid to remove things like carbonates from the water. Then we add our testing reagent. So our equation for this would be, say we're testing for the sulfate ions in something like potassium sulfate. We would take our potassium sulfate and we would add our testing reagent, barium chloride. Now remember, we've squirted in some nitric acid just to remove any possible false positives, to remove those carbonate ions. So we don't write the equation for that here. We may write that at another time if asked. But here we're making our observable precipitate. And if we balance this equation, you can see that will balance it. And if we do that as an ionic equation, it would be, we're testing for sulfate ions by using a positive ion, because they're a negative ion. We're using barium ions to make the insoluble barium sulfate. Barium sulfate is a group 2 solid, so a white precipitate would be seen. And that's of barium sulfate. Why is nitric acid added? So we said that was to remove other ions that would form a precipitate. E.g. carbonate ions. So carbonate ions react with the acid and they're removed because they turn into carbon dioxide and water. And so they're no longer there, but that hasn't impacted the next test. Would it be possible to use sulfuric acid instead of nitric acid? Well, the answer to that is no, as sulfuric acid contains SO42- ions, so would form a white precipitate. We could use hydrochloric acid, but we wouldn't be able to use sulfuric. Nitric always works. Could a solution of magnesium chloride be used as a reagent for this test? Explain your answer. So we're trying to test for sulfate ions. And sulfate ions are negative, so remembering that sulfate are negative, if we used magnesium chloride, we'd be using magnesium ions. So this would form MgSO4, which is soluble, so only a colourless solution is seen.